Hello everyone. Today we are going to discuss about a very important organic name reaction, Reimer-Tiemann reaction. Reimer, it is the name of the scientist who first discovered the reaction. Reimer-Tiemann reaction. Okay. In this reaction, we can convert a phenol. A phenol means aromatic hydroxyl compound to a salicylic, okay, benzene with hydroxyl and aldehyde group, salicylic with addition of chloroform and sodium hydroxide aqueous. Okay, phenol plus chloroform, CaCl3, methane. Here 3 hydrogen has been replaced by 3 chlorine atom. Then sodium hydroxide, it is a base, and in aqueous medium. Okay, aqueous means with water, not anhydrous, I mean not dry, it should be aqueous in water. Then if we reflux, suppose we reflux it in a RB, round bottom flux, then what happen? At first we will get sodium salt of salicylic. Okay, this aldehyde group may enter here or in para position also. Okay, in ortho and para position, but here the ortho position will be more stable due to the hydrogen bonding. We will discuss it later. Now if we acid hydrolysis, H positive plus water, so H3O positive, if we do acid hydrolysis, then this sodium will be replaced by hydrogen, so but we will get our desired product, salicylic, ortho salicylic. So we will get this product. So here you can see phenol is acidic, because here due to the aromatic property of the benzene ring, or here there is conjugation, so here the O negative charge, I mean the phenoxide ion, is stabilized due to the conjugation in this ring. So we know if the conjugate base is more stable, then definitely the parent acid from where this conjugate base come, that acid is more acidic. So here, as the conjugate base is stabilized due to the resonance, okay, or Placer effect in this ring, so phenol is acidic. Clear? Now if it react with chloroform and sodium hydroxide and reflux, then we will get salicylic. Clear? We can get aldehyde in ortho position and in para position also, but here ortho position salicylic is more stable, or it is the major product due to formation of hydrogen bonding with hydrogen and oxygen. Clear? Now we will see the mechanism of this reaction. Now we are going to discuss about the mechanism. Okay, here initially, in initial step, what happened? The base, okay, OH negative coming from the base sodium hydroxide will react with hydrogen of chloroform. Okay, as this carbon hydrogen bond, here it is acidic because here there are 3 chlorine atom, electronegative chlorine atom attached with carbon. As a result, this electron has a tendency to move towards carbon. So this hydrogen is always ready to go from chloroform. So when the strong base come near to this molecule chloroform, then it can easily attack this hydrogen. So as a result, this carbon hydrogen bond will be broken, and this sigma bond electron pair will go to carbon. Okay, now what happened? OH negative and hydrogen, it will release as a water, and then what happened? This 3 chlorine atom remain with carbon. This 3 chlorine atom remain with carbon, and as this sigma bond electron pair goes to this carbon, so it will be now negatively charged. Why it is negative charge? Because now here you can see in the valence of carbon, valence shell, there are 5 electron, 1 2 3 4 5, but there should be 4 electron in the valence shell of carbon. Now there are 5 electron. Okay, so negative charge should be written here. Now you can see there are negative charge on carbon. Okay, so it will try to remove this negative charge from here, and you can see here chlorine atom is there, 3 chlorine atom, these are electronegative, so 1 chlorine atom will be released from here to make carbon stable or neutral. So it will be released. Okay, any one of these 3 chlorine atom can be removed, so it will be released. Now what will remain? Now here we will get this compound carbene. Generally in carbene you get hydrogen and hydrogen here, but here we will get 2 chlorine atom in place of hydrogen atom. So here you can see there are 4 electron, 1 2 3 4 in the valence shell of carbon, so it is neutral, but here octet is not filled up. You can see if we see the overall electron in carbon, then you can see 1 2 3 4 5 6, so total 6 electrons are there, but octet is not filled up because there should be 8 electron. So as the octet is not filled up, so it is electron deficient, so it will act as a Lewis acid. And on the other hand, another factor, there are 2 electronegative chlorine atom attached to carbon, so it will pull the electron due to minus I effect from carbon. So for that reason also this carbon will become partially positive charge. So due to these two combined effect, carbon is highly electron deficient and it will act as a Lewis acid. Now the phenol will react with this carbon. How it will react? Let's see. Now here we will draw phenol, as it will going to attack the electron deficient carbene. Here there are 2 lone pair present here. Okay, so 1 2 3 4 5 6, so oxygen valence is 6. Okay, now it is a neutral molecule. Now this lone pair will move to this carbon oxygen bond, so it will become pi bond. So now this carbon will become electron dense, more electron dense. As a result, this bond will break and it will now attack this carbon. I mean this bond will break and goes to this carbon and it will become negative charge. After that it will attack, okay, and directly attack the carbon. Now what happened? Now you can see we will get a structure like this. It will remain here. Now it will become double bond, okay, because this lone pair goes here. Now it will remain hydrogen. Now there are 2 lone pair, 1 lone pair remain. As 1 lone pair move to this carbon oxygen bond and make it double bond, so remain 1 lone pair. So now count the electron 1 2 3 4 5. So 5 valence electron in oxygen, so there should be how much valence electron? There should be 6 valence electron in oxygen, as its atomic number is 8. So here electron deficient oxygen, so we have to write positive charge here. And now this carbon will attach with carbene, so chlorine. So this lone pair remain here. Now you count the electron 1 2 3 4 5. It should be 4, but 5, one more electron, so it will become negative charge. Now what happened? You can see clearly here oxygen is positive charge, so oxygen is electronegative, and at the same time now positive charge is there, so it is highly unstable, so it will be neutralized by removing this bond, pi bond, to here. Now here one hydrogen atom present, so this carbon hydrogen bond will break and it goes to this bond. Okay, it will become pi bond. Now this hydrogen will be taken by this negative charge. Okay, very simple. Now we'll write the compound. It will look like this. It will become OH. Now CH, Cl, Cl. This hydrogen goes here, become this, and carbon hydrogen, and chlorine, chlorine. Now what happened? Now in the medium there is OH negative, so coming from base sodium hydroxide, this OH negative will replace this 2 chlorine. Okay, replace this 2 chlorine. Now the structure, sorry, here one double bond will be there because this carbon hydrogen bond come here. Now here what happened? You can see this hydroxyl will be here. Now this 2 chlorine will be replaced by 2 hydroxyl group. Now keep in mind that if 2 hydroxyl group present to carbon, so that compound is highly unstable because these 2 oxygen atom are highly electronegative. So if 2 highly electronegative hydroxyl group present to carbon, then definitely that carbon is unstable, so it will be neutralized by, or it will get a stable form by rearrangement. So it will go here, and this, it will become double bond, so this carbon oxygen bond will be broken and it will release as hydroxide. Now we'll get the final product here. Okay, hydroxyl and aldehyde. Clear? So it will become double bond and hydrogen is there, so aldehyde group. So in ortho position we will get salicylaldehyde. Clear? Now we will take a very important example generally used to come in entrance exam, the pyrrole compound, a heterocyclic aromatic compound, pyrrole. The structure is like this. Okay, 5-membered ring, nitrogen will be there, and so one lone pair will be on nitrogen, on, and it is hydrogen. Now if it react with chloroform and sodium hydroxide aqueous, so what will be the product? It is a very important question. Now the confusion comes here that in what position the aldehyde group will be attached. Okay, because here one lone pair is present, so due to delocalization, okay, this lone pair can go here. Okay, after that this bond can go here, this pi bond can go to this carbon, so it will become negatively charged. So we can think that this aldehyde group can attach to this position. If we show the position 1 2 3 4 5. Okay, but if you see carefully, then you can see here the conjugation if we show from left in that direction, here you can see this lone pair can go here, so this carbon become more electron dense, electron density increases here, so it will, this bond will break and it will go here. Now this bond will again broke because it will become electron dense. Now it will go to this position. Now there is no there is no option to go in this direction because it will again move in a cycle. So this delocalization will finally end at these two position. Clear? After that, if we again move forward, then a cycle will be maintained just. Okay, so here this two position will become more electron dense, so here the aldehyde group will be attached, so the product will be looked like this. Here aldehyde. Clear? Don't forget it. Okay, just you practice this thing, and for the mechanism you should practice, and it is very easy to forget organic chemistry name reaction. So if you don't practice, then definitely you are going to forget it very soon. So just study it first and write uh, again and again, then you can remember it, or you will get the concept for long time, or you will not forget it very soon. Okay, thank you.